everyone, we are Team Agua in Guatemala. We had the privilege last January to visit Guatemala during our Global Health Design Study Abroad class, where we shadowed local nurses as they visited some of the residential areas. We also worked with local agriculture engineering students at ETech High School to come up with engineering solutions to local health problems. The class was formulated as a design competition, so we were separated into different groups that each came up with a different health problem to tackle. The group that won the competition consisted of 2 bioengineering students from the University of Colorado and Shoots, and 3 students from ETech, Michelle, Andres, and Carlos. With the help of a local nurse, Nimsy, they identified a problem they face with standing water around the residential kitchen well called a pila. They explained that there is a great need for a drainage system in tropical low-resource communities where they have high prevalence of mosquito-borne illnesses. As seen in the video, the standing water pools are created due to improper drainage around the kitchen and serve as a breeding ground for mosquitoes. Children are more likely to be exposed to these illnesses when playing around the house. Moreover, treatment is often unavailable, leading to an increase in the inability to attend classes and mortality rates due to these illnesses.
We brainstormed many solutions to mitigate this problem and came up with a drainage system that will redirect the used sink water away from the residents' homes. The drainage system is made up of PVC and flexible pipes, and it allows the locals to use their sink without creating the standing pool, thus reducing the opportunity for mosquitoes to use the water as breeding grounds, and in turn reducing the quantity of mosquito-borne illnesses.
This device was designed with simplicity in mind, so it is easy to build, easy to maintain, and it has long-lasting materials. We have even included a filter, which is made of coconut husk that is held within 2 2-liter water bottles. And this light filtration introduces a secondary benefit because the filtered water can be potentially recycled for the irrigation of crops. The filter also allows for large food waste from not entering into the drainage system. So this component is easy to assemble and replace, as the water bottles can be removed from the piping and the waste can be discarded. New coconut husk can be added, and that's a fresh, brand new filter that can be added onto the system. So once this type of drainage system has been accepted community-wide and adopted, individual drainage systems can all feed into a collector channel, which can form an irrigation ditch.
Our first prototype was tested in Guatemala using the pilas at the ETech schools. This test successfully removed the water from the sink without leaks, but we had some issues with the inconsistency of flow. We solved this problem by introducing a ventilation component to depressurize the system, which provided a faster flow rate to evacuate the water from the device. We plan on testing the prototype using 2 liters of water with about 50 to 100 grams of food particulates in 3 different trials.
After our verification testing, we hope to receive approval to conduct testing in Guatemala. We plan to conduct preliminary experiments with our Guatemalan counterparts, who have the funds to do so. We are planning to quantify the presence of mosquitoes before and after the installation of the device by collecting samples from standing water and insect traps to determine the presence of larvae and mosquitoes.
Being able to be part of this project gave us the opportunity to seek and hear out the locals and implement their input every step of the way. For me personally, as a native Spanish speaker, I was able to explain to them the full process of this design and help them realize how essential their voice was in this. We brought the idea to the community to get their feedback, and after discussing materials and providing a demonstration, many of the community members agreed that this device would actually be valuable at their homes. The prototype cost about $10 US when we made it, and the locals said they were willing to spend as much as 100 quetzals or $14 US. So this clearly shows that the cost of the device falls under the budget the locals want. And as a winning team with this design, the University of Colorado and ETech High School contributed to $200 for the winning team. And as of right now, the funds are available for Michelle, Andres, and Carlos to take this prototype into the community and let local leaders know about it. Thank you for watching. We hope that this video gives you an idea of what our design entails and how it contributes to a safer and healthier space in local homes in Guatemala.